Okay. So
That's it. Right.
we've covered quite a lot of territory in terms of how you detect exoplanets. And there are many detection techniques: pulsar timings, radial detection, transit detection, astrometry, transmission spectroscopy, and all of those have been indirect ways of detecting extrasolar planets. You don't actually see the planet. You see the atmospheric absorption lines, perhaps, of the planet, or the fact that the star is moving, but you don't see the planet. You're inferring the existence of the planet. Today, we're going to talk about direct imaging, the pictures we've actually taken of planets around other stars. And this is very difficult to do. As you might imagine, these stars are trillions of miles away. The planets are smaller. They don't give off any of their own light. They have reflected light. And so the analogy that we've been using is a car with bright halogen headlights at a mile away at night, and you put a pea or a golf ball set right next to it, and then you try to image that pea or golf ball. Very hard to do, but it has been done. This is the first image of a planet around another star. This was the 2M1207b. Remember our naming convention that the first planet you discover around a star is given the letter B, and then successive planets are C, D, E, and so on. This picture, this actually a series of pictures, was taken with the Very Large Telescope at the European Southern Observatory in Paranal, Chile. It was taken in 3 different infrared wavelengths, and of course, adaptive optics were used to account for the absorption and the kind of the tumultuous nature of the atmosphere. This picture was taken back in 2004, and it's no surprise, I think, that this the planet that was imaged here is 5 Jupiter masses in mass. Right? It's a big planet. Therefore, it has a large surface area, and it's reflecting lots of light. So that's what you would tend to find. It's orbiting at about 55 AU from its star. It's 55 times the Sun-Earth distance. And it's about 230 light years away. So this was the very first, back in 2004, image of an exoplanet. Here's another kind of time series of multiple planets around a star. These are 7 images of the star HR 8799 system. And you can see at least 3 of the planets, actually 4 if you go out to the upper right, orbiting very clearly. These images were taken from the Keck Observatory over a period of 7 years. So these are kind of 7 individual images that were kind of interpolated to get a smoother orbit. And these images were taken between 2009 and 2016. What you're seeing here are 4 super Jupiters, right? Once again, big planets, lots of surface area to reflect with. And their orbital periods are decades to centuries, so they're quite far from their star. But I just thought this was an amazing animation.
It is. It's amazing.
So I mentioned there haven't been many visual detections of exoplanets. There have been about 25 to date. This is a listing of 7 of them, I guess, 3, 4, 5, 6, 7, no, more than 7. And you can see that most of them are fairly massive, right? More massive than Jupiter. Radiuses that are larger than Jupiter, right? Again, no surprise there. And orbital periods and so on and so on. You can see the information that's displayed there. And if you want to find out more about that, of course, you can go to the NASA Exoplanet Archive. And I always display the NASA Exoplanet Archive homepage, as well as now Eyes on Exoplanets, which I will talk about each time we get together. This is the 3D animation, interactive animation that NASA Jet Propulsion Laboratory put together of all the known exoplanets. So I will end there. That is our sixth exoplanet detection story.
And I will put those links for the Exoplanet archive and eyes.nasa.gov. I will put them in the description of the video for you viewers. So well worth investigating both those. Fantastic. So have we reached the end of the Exoplanet series then, Lou?
There's at least one more.
Oh, fantastic. Good.
That has to do with, I'll just say, that has to do with using general relativity to detect exoplanets. We'll get to that next week.
Intriguing. Sounds intriguing. Okay.